So we'll go for now solids with its axis inclined to one plane and parallel to the other. So in that we'll go for solids inclined with its axis inclined to HP and parallel to VP. Then we'll go for axis inclined to VP parallel to HP. So inclined to HP parallel to VP, inclined to VP parallel to HP. Two conditions. Okay. So I'll go for the first condition in that. Okay. So if we keep the solid this below this XY line, this is nothing but your horizontal plane and this is vertical plane, right? Okay. So it's nothing but the solid is resting on its base on HP. So prism is resting on its base on HP. So when I want to keep the solid, okay, so again if I want to give the axis of this solid to incline with HP, then we're going to have two conditions, okay, in most of the problems, okay. Saying that, okay, so when the axis is inclined to HP and parallel to VP, so it will going to rest on one of its base edges on HP or resting on one of its base corners on HP. Because when I tilt, so I can tilt about this corner, you can see about this corner, or tilt about this edge. Okay. So in these two conditions, you'll go to find the problems. Okay. So I'll go for the first case. Okay. Having one of its base edges resting on HP with the prism having its axis inclined to HP and parallel to VP. So then I can just create a problem, something like this. A triangular prism of 30 mm base edges and a height of 60 mm is resting on one of its base edges on HP such that the axis of the prism is inclined at 30 degrees to HP and parallel to VP. Draw its projections. Okay. So that is the problem. And I'll explain how to draw the solution for this problem. Okay. So if you have, when you read the sentence, you find out whether the solid is resting on its base on HP or resting on one of its base edges on HP or resting on one of its base corners on HP. So based on that, I have to draw this first view. So because when I draw the first view, always you're going to keep the solid resting on its base on HP. Then I'll change the position, okay, in the second step, okay, so that I can satisfy the condition what he has given. So initially, always in all the problems, they're going to keep the solid, any solid, whether it's a prism, pyramid, cylinder, or cone, okay, resting on a plane, okay, horizontal plane or vertical plane, depending upon where the conditions came. So in this case, because it says it's resting on one of its base edges on HP, I have to keep the solid resting on its base on HP, so that when I tilt, so that will satisfy that condition that it's resting on one of its base edges on it HP. Okay. So in that case, so always whenever you have any problem saying that any prism is resting on one of its base edges on HP, go for drawing that base edge perpendicular to XY line. Then you construct that polygon. Whether it's a triangular prism, construct a triangle. If it is a square prism, construct square. If it is a rectangular prism, construct rectangle. If it is a pentagon, construct pentagon. Right? If it is hexagon, construct hexagon. So now it's a triangle. I'll go for taking triangular prism. Okay. So I'll go for drawing that triangular prism. So in the top view, I'm going to draw this position. So A, B, C, and A1, B1, C1. So I'm going to keep that edge which is going to rest on HP on the right side, and I'm going to draw in this way. So having one of its edges on the right side, okay, and that should be perpendicular to XY line. You construct your polygon on the left, okay. So that when I bend, okay, that should rest on towards right, okay. It should rest on the edge which is on the right side, okay. So that way, okay. So then I'll go for projecting this. We'll see how exactly it looks in the front view when it is resting on its base on HP. This is the condition where the solid resting on its base. So the prism resting on its base. So move up by the height of the solid, whatever he has given, the prism. So draw the top. So then this is ABC with the dashes because these are all the front views. So B I can see, so A will be in the bracket. So A1, B1, C1. So A1 will be in the bracket. So this is the axis, so I can represent the axis, go for a chain line, a big dash, a small dash, big dash, a small dash, big dash, a small dash. So O dash, O1 dash. So and this is the base, right? Okay. So that should have a thick line compared to this. So XY line should be drawn using H pencil, whereas I should differentiate actually this the base with the XY line, right? Okay. So it should be dark compared to this XY line. Okay. That's why I use HB pencil for drawing all these edges, visible edges. A thick line, use HB. For medium thickness, you can use H pencil. And all these projectors should be drawn using very thin lines. So use to H pencil. Don't press it. Okay. So let it be very thin. Okay. So when you draw them. Okay. So now I'll go for this position. Okay. So to give the axis inclination to HB, because it says the axis is inclined at 30 degrees to HP and parallel to VP. Say that is the condition by defining all this problem. Saying that, okay. A triangular prism of 30 mm base edges and a height of 60 mm is resting on one of its base edges on HP such that the axis is inclined at 30 degrees to HP and parallel to VP. So in that case, okay. So kept the solid in this position, having that edge which will going to rest on HP perpendicular to XY line, okay. So that when I bend, it should going to rest on, it will going to rest on that edge, okay. So then, so in this way, if this is a horizontal plane when you are looking in BP, so this is now resting on its base on HP, okay. So then I can see turn the solid to give its axis which is previously perpendicular, okay. So the axis which is previously perpendicular, that will be inclined, okay. So go on inclining. So if the axis is inclined, okay, so this is the axis, right? Okay, so the axis is inclined at 30 degrees to HP, okay. So this is horizontal plane when you are looking at the vertical plane. See, if this is vertical plane, so this is horizontal, okay. So the axis will be inclined at 30 degrees to VP. Then automatically we'll see that the base will be inclined at 60 degrees. If the axis inclines at 30 degrees, base will be inclined at 60 degrees because they are mutually perpendicular. I'll show you that by drawing the base. Instead of drawing the axis inclined at 30 degrees, I'll draw the base inclined at 60 degrees. Then I'll show that the base will automatically incline at 30 degrees. So 90 minus that 60 degrees what I've taken. Okay. So I'll go for taking this length and incline this base at 60 degrees. So this is A1 B1. Okay, A1 I'll write here A1 B1. As I'll take this length and I'll transfer here to get that point C. 1 dash, okay, right? Okay. So then I'll locate this axis. I'll just transfer here. So this is the axis line. If I draw the axis line, okay, see. So if the axis inclines at 30 degrees, the base will be at 60. So because I've taken base at 16 drawn, because for this base this axis line will be perpendicular, this becomes 90 degree, so these two should be 90 degrees. So if this is 60, this has to be 30. So in that case, because yes, in the problem it is mentioned that the axis is inclined, don't dimension this, instead you take this at 60 degrees, but while dimensioning you dimension only this axis, saying that axis is inclined at 30 degrees to horizontal plane. Then because all these longer edges will be parallel to the axis or perpendicular to the base, you can complete the same view here, okay. So then this will be the view, same view redrawn in this position. So this method is called as change of position method that you have learned in your projection of planes, okay. So there are two methods, change of position method and auxiliary plane method, right? Okay. So this I am drawing by change of position method. So in this position, okay, so how exactly, so this is your front view, how exactly it looks in the top, okay. So when it is turned in this position, that is your view, okay. So I'll project all these points on HP, including the axis and O1 dash, okay. O dash and O1 dash, okay. If I draw locus from all this, so then I can locate that, okay. So this is A and this is B. As soon as you mark the point, you name it. This is C. This is A1, A1, right? Okay. So A1, B1, B1. Go in the order. Don't miss anything. So this is C1. So I'll project that O1 dash and also O1 O. So this is O. A and A, B and B, C and C, okay. Same way A1, B1, B1 intersecting, right? Okay, locus line and the axis line. So in that way. So now to complete this view, so there may be some edges invisible. You have to identify which edges are visible and invisible edges. So all visible edges will be marked with a thick continuous line, whereas invisible edges should be marked with dotted line. For that, you can follow this procedure. Look from the top, okay. So check out which end face is nearer to the observer. So you can look at the end of the axis, okay, from a horizontal line. If this is closer compared to this, so that end is visible. In that way you can make out. Or you can see that, see the complete end face you can reach actually by drawing a lines perpendicular to the XY lines. Nothing but you can see this end face, but not this. You have to pass through the solid to see this face, right? So in that case, if the end face is one of its end face which is nearer to VP is the top end face, so complete all the edges of that end face with a thick continuous line. So all edges are visible. So then you go for the outermost edges. So all outermost edges are visible. So complete all edges with a thick continuous line. So then this the outermost, then this the outermost. So then what about this CC1? That's the topmost edge, okay? So you can see. So mark that, okay? So otherwise, if you can see this end of the CC1, and if that C1 is the outermost end of that line, so both the ends you can see is nothing but you can see the complete edge, okay? So in that way also you can make out that this CC1 is a thick. So once you complete this, so this is our surface, this is again one more surface, so there should not be any dark line now passing through that surfaces because you're not going to have any edges on the surface, okay? So in that case, so the A1, B1 is not joined, so that will be now a dotted line. That becomes the invisible edge. So draw with a dotted line, right? Okay. So the axis is overlapping here. Only to this you can see, just make that only that axis a big dash and a small dash to this length, okay, where you can mark, okay, because that's not overlapping. You have to show that axis also to this only for this length, okay. This is the solution for that problem what I said, okay. So we'll go for the second case. When its axis is inclined to VP and parallel to HP. So inclined to VP and parallel to HP. So in that case, you have to keep the prism something like this, okay. So that the base should be in VP. So then you bend about this edge so that you want to make the axis keeping it parallel to the horizontal plane. Just turn like this to give the axis inclination to VP. Right, okay. So I'll go for now the corner position. Anyway, I'm going to have resting on its base edge or resting on one of its base corners. In that way, I'm going to find actually the problems, okay. Just I'll explain the same thing now. Having its one of its resting on one of its base edges in VP and the axis is inclined to VP, the same condition what I did now here for this problem, okay. So in that case, we'll go for drawing and divide this into two parts, XY line, okay. So then because I should have, because it's in the problem, if the problem is something like this, a triangular prism of 30 mm base edges and a height of 60 mm as one of its base edges lying in VP such that the axis is inclined at 30 degrees to VP and parallel to HP. All dashes. So then you have to keep the solid in VP, having its base in VP. So project. So now the base is in VP. So this is the base in VP. And then based on the height of the solid, I will take that height of the solid that I can see in the front top now. Okay. The height I can see in the top because I'm keeping this base in VP, not on HP, something like this in the previous case. Okay. So then the axis line I can project big dash, a small dash, big and a small. So this is A1, B1, C1, A, B, C. So which one to put in the bracket now? Because I can see A, so I have to put the B in the bracket, okay, because I cannot see the B. Okay. So this is O1, this is O1, right? Okay. So now, okay. So now if I imagine this XY line as vertical plane, okay. So now the solid is something like this, where the base is in VP and the top view I'm looking like this, right? Okay. So this is my view. Base is in VP, right? Okay. Base is in VP, and I can see the length of the axis. Okay. So then I have to incline in the second position, change of position method. I have to incline the axis, keeping the axis parallel to HP. I have to incline the axis. So now previously it is perpendicular. I have to incline. So perpendicular is nothing but 90 degrees. So now I have to incline that to 30 degrees. So the same procedure I will do. I'll go for inclining the axis. The base I will incline at 60 degrees because it says axis is inclined at 30 degrees. I will incline the base at 60 degrees. So I'll take this length, okay. So this is A1, B1. I'll take this length, I will mark it here. I'll take, just transfer using compass or divider. Then I'll take this length, the complete length. I can get that point C1. So then I'll go for drawing this now, okay. I'll redraw the same view. Axis O1. So this is O, big dash, small, big, small, big, small, okay. So then this will be ABC, be in the bracket, right? Okay. So if I project, so now, okay, so that will be the view of exactly C in the front, right? Okay. I'll project now, okay. From all this, just project, okay. So now draw the locus from all the points, okay. Same way now, okay, so I'll go mark this A and A. This is my A, B and B. This is the point B dash. C and C. This is C dash. Okay. Same way, I'll go in the order again. A and A1. So this is A1 dash. This is B1 dash. This is C1 dash. Okay. So then again, I'm going to look from the now to check out which end face is visible. I'll look from now the front view. This is front. I'm looking from the front. Okay. So then I can see this end face. So I can draw all the edges of this end face with a thick continuous line in the same way what I did in the previous case. So then this is the outermost edges. I'll complete all the outermost edges with a thick continuous line because all outermost edges are visible, right? Okay. So then I can see the CC1. So it's a complete visible edge. Okay. So then the only edge invisible is this A1, B1. So I have to invisible edge. I know how to draw the invisible edge. Okay, by a dotted line, right? Okay. So now this is the solution. So this is the axis O, and this is O1. So till here, a big dash, a small, a big. That way I can represent only for this length, right? Okay. This is when the prism is having one of its base edges in VP and its axis inclined at 30 degrees to HP. Okay. So dimension for the axis, because I've taken 60 degrees to the base, the axis will automatically incline at 30 degrees. So 30 degrees to VP and parallel to HP. You can see that parallel to HP here. So this is the condition. Okay. So where one of having a prism or any solids, okay, with its axis inclined to one plane and parallel to the other, inclined to VP parallel to HP. This is inclined to HP parallel to VP. So resting on one of its base edges on HP, having one of its base edges in VP. So this is having one of its base edges on HP. This is having one of its base edges in VP. The same way I can have even the base corner. In that case, resting on HP or in VP, I'll go for only with the resting on HP and not other VP. Okay. So in that case, I'm going to find a problem something like this. I'll take a square prism. Okay. A square prism of 30 mm base edges and a height of 60 mm, has one of its base corners on HP. So always it rests on one of its base corners on HP. See, a square prism of 30 mm base edges and a height of 60 mm has one of its, or I can say it's resting on one of its base corners on HP. A square prism of 30 mm base edges and height of 60 mm is resting on one of its base corners on HP such that the axis is inclined at 30 degrees to HP and parallel to VP. So previously I had a problem saying that it's resting on one of its base edges on HP. Now resting on one of its base corners on HP, the same condition, axis inclined to HP and parallel to VP. I'll take the triangular prism only, then we'll go for that again. So in that case, you go for drawing to have the corner on the right side, something like this. So A, B, C. So then you can, if it is a square prism, then you construct a square, something like this, so that you're going to have a corner on the right side. If it's a pentagon, you construct a pentagon so that you're going to have a corner on the right side, so that all the corners should make equal. See the line, this the base edges forming that corner. So the edges actually forms that corner. Okay. So or the rectangular surfaces that forms that longer edge. Okay. So that should make equal inclination with the vertical line, if you are assuming a vertical line here. So in that way you have to draw. If it is resting on one of its corners on HP, so you have to draw in this way. It's a square prism, you have to draw a square prism, something like this. So that if I draw a line, this, I'll just draw it for you here, okay? Something like this. Draw this a square in such a way that, okay, if I assume a line here, so that should make equal inclination. In that case, I should draw a diagonal parallel to XY line, so that these two will be at 45, 45, because in that case, even this makes an angle equal inclination with the vertical line, so that should make equal inclination with the vertical line. The same I can construct even a pentagon, okay, so having that corner, okay, containing the edges containing the corner should make equal inclination. That way I have to draw this view, okay. So then this is the top face, so A1, B1, C1. The axis, so for this position, so resting on its base and HP initial position, I'll go for drawing this solid with the given height, okay. So if it is 60, I'll move up by 60, then I'll complete it. So this is the axis O1. Same axis I'll project here, so I know to represent the axis a big dash and a small dash, right? Okay. So this is O dash and this is O1 dash. So this is ABC with all dashes. So B I can see, A will be in the bracket, okay. So A1, B1, C1. So A again in the bracket. Okay. So this is now, okay, resting on its base on HP, right? Okay. So now, so this is the condition. So if you imagine this is the axis, I have to keep that corner, okay, to come on the right side. If I bend towards right, it should rest on that corner, okay. So you can see that corner resting on this corner. So I have to tilt, okay, such a way that it should rest on the corner. I'll redraw that, okay. So in that case, the axis is inclined at 30 degrees, this base will be inclined at 60 degrees, or this longer edges will be inclined at same inclination with the axis. In that case, I can draw only for the prisms. I can draw this, I can start this drawing CC1 inclined at 30 degrees, or I can start drawing the view with the base inclined at 60 degrees. Okay. So then automatically this will be inclined at 30 degrees to the digital upside. Okay. So if I draw a line perpendicular to this, because the base will be perpendicular to this, okay, so I will take that same height, I will transfer here, okay. So this is my A1, B1, and this is the axis. So take that axis, so this is O1. So the base is inclined at 60 degrees, this is 90, plus this will be 30, right? Okay, so then if I draw the axis now passing through this big dash, a small and a big, okay, so we'll see that if this is 60, this automatically it should be 30 degrees. So go for redrawing this same sketch which is available here, okay, complete the view, okay, draw that. So this is C1, ABC without dashes. So you can see that the corner only C1 is resting, so C1 is the corner, okay. So this is the position, okay. So this is the condition where he says resting on one of its corners of its base on HP, so resting on the C1, corner C1 on HP, such that the axis is inclined at 30 degrees to HP and it's parallel to VP. So in this position, how exactly it looks, so this is the position, okay. In the top view is nothing but, okay, your final position, okay. So for that I have to project now. Project all the points perpendicular to XY line, okay. Then draw locus from all this to maintain the distance in front of VP the same, okay. Then I can look at the point, so this is A and A, right, okay. So that becomes A, B and B, that is your B, C and C is C, okay. So this is A1, this is P1 in the same way, right, okay. C1, C1, so this is C1, this is O1, this is O. So now I'll follow the same procedure, okay. I'll look from the top, so this end face is nearer to the observer compared to the base, okay. So the top end face is nearer to the observer, so I can complete all the edges of that end face which is nearer to the observer. So with a thick continuous line, then I'll go for drawing all the edges, the boundary edges, okay, with the continuous line, okay. So if I draw something like this, so this is the surface and this is the surface. So the complete boundary is now two surfaces. So I cannot have any line on the surface, because I cannot have any line on the surface, okay. That should be a plane figure, right, okay. So in that case, so all these edges which are not joined now, A1, C1, B1, C1, okay. So all that should be a dotted line, okay. So that becomes invisible edges. That's why you can see only the surface here. So that will be exactly below that, okay. In that way I cannot see that, so that becomes invisible edges, even that C1 also, okay. So in that case I'll go for drawing all these edges with a dotted line. So again this becomes a dotted line. So C1 is a dotted line, invisible edge. So give preference to the edge, okay, equally spaced, equal length line. So even though axis coincides here, need not give the preference to the axis, go for this. Only for this, you can here you can show the axis line, whereas this should be marked with thick dotted line, right, okay, invisible edges. The same you can have even in VP, okay. It's not required. So this is the solution for that problem, okay. So where he says a triangular prism of 30 mm base edges, you dimension all that, okay, 30 mm base edges and a height of 60 mm, okay, resting on one of its base corners on HP, so that the axis is inclined at 30 degrees to HP and it's parallel to VP. Draw its projections. So just project all this, get your view. This is the second condition, okay. So where the axis inclined to one plane and parallel to the other. So axis inclined to HP can make the difference now. This is having one of its base edges on HP, whereas here we're going to have base corners. So in that case you can see that that base edge which will going to rest on HP I kept in the right side. I have constructed my polygon on the left. So I made that A1, B1, the base is to touch XY line is nothing but it's resting on HP. So I have redrawn this view, same view redrawn in this position, then projected to get this view. This is the solution when they say a triangular prism of 30 mm base edges and height of 60 mm as one of its base edges on HP, so that the axis is inclined at 30 degrees to HP and parallel to VP. Plus this is the condition where same condition only says triangular prism of 30 mm base edges and 60 mm height is resting on one of its base corners on HP. This is resting on one of its base edges on HP, whereas this is resting on one of its base corners. In that case, I should have a corner on the right side. If it is resting on the edge, I should have edge on the right side, right? Okay, so I'm having a corner on the right side, so then when I tilt about this corner, automatically it's going to rest on HP. So in this position I can redraw based on whatever the inclination with HP is given. Okay, so redraw that inclination. In that inclination you project, you'll get your solution, and you know how to identify visible and invisible edges. So this completes, okay, the second position, where the solids with its axis inclined to one plane and parallel to the other. The next class will go for the solids with its axis inclined to both the planes. Okay.